Dudes, I'm here again with another part of the React Clone series. And yeah, I know I said that it's kind of dumb, but to be honest, there are a lot of things that left untouched, among them the key issues, like literally. So, what I want to do is um, go over why keys are necessary for optimal, not just performance, but optimal and reliable work in React when you have dynamic children. And by just dynamic children, I mean something you map over, or so you return uh, you return a number of elements that are unknown at compile time. If you compile time, we can say that. So for example, if you have a if in our case, like, React doesn't know how many to-dos we'll have, and obviously the user can create new to-dos, whereas here, like, the only difference, because this is an array in the end in the reconcile children array function, and this is an array as well, the only difference between the two is like, this is kind of known at the time React compiles, because it's either 3 or 4, right? So yeah, it can vary from it can vary from 3 to 4, but based on the state, but still it's kind of fixed. Whereas in the to-dos, or just imagine that you're fetching some API that can change at any given point. So yeah, you always receive that warning. So we have this key, but it does absolutely nothing. But in normal React, if you don't provide it, you always receive that each child must provide its own unique key. And what we do is simply, most of the time, is like we put the index there. And if you read the docs and some blog posts, that's one of the first things that people tell us not to do, because it's not reliable. So I want to dig into what's behind this, why would you need to have a key, and what is the exact problem. So the exact problem is, in our case, is still present in not even the dynamic children, but the static children. And to actually get into, I'd like to show what the problem is. So if we think about this, we have an array here that has a length of 4, but if I click on a mount, that it has a length of 3, because this is only visible in the counter. So the way it works is, we initially have an alternate tree, which, when I click on the button, has 4 items, and the work in progress fiber only has 3. So what happens is, then when we get to the end of the array, because it's just 3, we recognize that there is an alternate, and that means that it has no corresponding work in progress fibers through. According to our implementation, we just simply put a deletion tag onto it, and the algorithm later takes care of everything, and so reconcile takes care of everything, and it will get deleted eventually. So here it is. So we ran out of indexes, so we only have an alternate, so the while loop keeps iterating. But since this array children will be out of bonding, if it was Java, it would throw out of array, I don't know what is the name, out of index, something like that, error, but it will just, in JavaScript, it will just simply return undefined. So it's undefined, but there is an alternate, so we just simply put a deletion tag. So it works just quite fine, and because the previous ones are untouched, so the 0th element will be equivalent to the first alternate fiber, so it just updates the props and stuff, so it works fine. Okay, so the problem starts arising when the element here is the first element. So now, obviously, it will look differently because the counter is the first one, but that's not the problem here, right? So the problem arises when we click on a mount. So yeah, that's not a problem. I mean, that's a problem, but that's not what I want to talk about. That's simply that simply needs to be addressed in the commit work. So we have a little issue here. Commit work. When we try to update, we ran into this problem before when the state node can either be a native DOM element or a React instance. And when it's a React instance, obviously, it does not have, it doesn't have an append child function. So what we need to do, because it's basically sort of a replacement, right, to the thing. So what we need to do is I need to have the same logic as with the placement tag. So let parent fiber equals item.parent, and we're just simply doing the same thing. So we are going up until we find a parent node that is that has an append child function. So that's another problem, but needed to be addressed. I think that will solve this. Yeah, okay, so that's pretty good. So now what happens is, as you unmount, the first item will disappear, but there are multiple issues with that. One of them is, like, if you think about it, the alternate first element is the counter, whereas the work in progress first element, which is the 0th index, I will use them interchangeably, is the to-dos. So instead of somehow magically knowing that the to-do is still there, it's untouched, it's just changed places, it now, what it will do, it sees that there is an alternate, however the types are mismatched. So what it will do is delete the counter and recreate the to-dos. So at that point we will have two to-dos, and when it goes to the next item, it will delete the old to-do. So it's a lot of extra work. So because if you just see this, then you as a human know that the to-dos are untouched, but how our reconciliation works at the moment, it just sees that at the given index there is a type mismatch, and you need to drop the old one, delete it, and create a new one. Also, we still have the to-dos in the next iteration. You would have access to that fiber with every property of it, but at the way it works, we don't know about it. So the third thing is performance implication. It's just a lot of unnecessary work. But if it were just simply native DOM elements, or native DOM elements or stateless component, that would be just like the performance implications, because it just gets recreated. But what about this scenario? So I am mounted, it's working fine, but if I create a few to-dos, it's not gonna work, because the to-dos are in the it's not gonna work. Sorry, so let's create it. I just want to demonstrate this. So let's do something that the counter has its internal state, I suppose. So let's put another counter. It might be confusing. Instead of this, let's just render a div here. I want a component that has its own state. So now if I unmount it, only this meaningless. Okay, so meaningless component gets unmounted, which is fine. Okay, so now let's play around with the counter object. So if I try to increment it, okay, and I just simply want to get rid of the meaningless component, what happens is, as you can see, that the increment goes back to 0. And now that's a serious problem, right? It shouldn't be. So it should remain the state to whatever it was before. And the reason that is actually quite simple. It's because, as I said, it's not considering it the same element, so it's not get updated. It gets deleted and then recreated. In other words, like if it was a class-based component, it will not invoke component did mount and just simply have an update cycle. It will have a component will mount on the old element and creates a new one with a blank slate, and the state will be a new one because of it's a blank slate, and it will create a component did mount lifecycle invocation. So that's the problem with that since it doesn't know the identity of the element, it treats it as a new one. And with stateful components, that's terrible. And that's the exact problem why you need keys, because otherwise, if you're rendering stateful components inside your dynamic children, so for example here, like they are absolutely stateless, so it's besides the performance implication, it's not a problem. But if you have a stateful component, then it will not preserve the state, because the components will get destroyed and recreated every time. So that's why we need to identify uniquely the rendered elements. Now, when it comes to like sort of static children, we will have a method. I try to figure out. Well, I think I will present some really dumb implementation of how I think React does it with sort of slots, how they insert elements into predefined sort of fiber slots, and that's the way how they manage the order, and they know that okay, that element is that no matter how many elements were in the previous iteration and how many elements we have in the work in progress fiber tree. But with dynamic children, that's impossible. So the keys are there to give you a unique identity, so you know that no matter what, you can be sure that that element is identical to the previous one. So if it holds any state, then it won't get destroyed, instead it will get updated. So that's the basic problem. I hope that I was able to demonstrate this. So now, even before we get into, so because we not solve this issue even with static stuff, let's first try to solve this in the next video. So see you until then, guys.